Hello everyone and welcome to my channel. Today in this session I am going to talk about Amazon compute services. So we'll look at all the different types of compute services that Amazon provides. So if you are new to cloud computing or just trying to understand at a high level what are these different types of compute services, I will try my best to explain in simple words. So let's start with Amazon EC2, and that is Elastic Compute Cloud. And this is a web-based service that allows you to quickly access a virtual instance on the AWS platform. So instead of you going buying servers or physical servers or machines, you can just open up the web browser, access the AWS console, and select what size of machine you want, what operating system, and how many cores, and you will be able to access that via that browser. You can also scale the compute power of the instance up or down based on the requirement. And there are mainly three types of instances that AWS provides. Number one is on-demand instance. On-demand simply means that there is no long-term commitment for using that instance. You can simply fire up the instance, do the work, and pay for the hourly rate of the instance. Now this is really good if you want to, let's say, test something really quickly and you don't want to plan anything on the capacity front. And also you do not intend to keep it for a long term. That would be for on demand. Second, we look at reserved instances. So on the other hand, if you are planning to keep it for a longer term and your workload is more predictable, you might want to go for reserved instance. You will also save a lot of costs on the reserved instance. Typically Amazon provides you about 72 to 75% of the discount on the on-demand if you go for reserved instance. And the longer the commitment is, the more discounted the rates are. So you can have for 1 year or 3 years, and based on how longer you want these commitments, the more cheaper you will get the reserve instances. And you can also sell your reserve instances if you don't need it. Let's look at the third one, which is spot instance. And these are the instances that are up to 90% discount rate compared to on demand. AWS has a reserve capacity for the data center, and this is basically the bidding for the unused capacity. You can even combine your spot instances with on-demand or reserved instances. Now, out of all three, reserve instance and the spot instance are the ones where you need some capacity planning for your environment. On-demand can then be used to handle traffic spikes as and when needed. Let's look at the second one, Amazon EC2 auto scaling. Now it is a service in which you can launch the EC2 instances automatically when the demand increases and terminate unneeded or unhealthy EC2 instances automatically and save money when the demand subsides. This can be done either by predicting the demand of the compute capacity or simply based on CloudWatch, which is a monitoring service for all your services on AWS. It also allows launching new instances automatically to balance any sort of latency requirements that you have in different availability zones. So to summarize, EC2 auto scaling does three things for you. It monitors the health of the running instances. It replaces any impaired instance automatically for you, and it also balances the capacity across multiple availability zones. Let's look at the next one, which is Amazon Elastic Container Registry. And this is a service which is very similar to EC2, kind of, except instead of instances, here we're talking about managing your Docker containers. So Elastic Container Registry, or we can call it ECR, is a fully managed Docker container registry that makes it very easy for especially developers to store, manage, and deploy Docker container images. Which means that as a developer, you don't have to, developer or an administrator You don't have to operate your own container repositories or worry about scaling the underlying infrastructure. AWS takes care of that for you. Let's look at the next one, which is Amazon Elastic Container Service, or you can call it ECS as well. And this is a fully managed container orchestration service, just like Kubernetes, except that this is fully managed and provided to you by AWS. Now, ECS can run cluster of virtual machines while managing, scaling, and scheduling groups of containers on those machines across multiple availability zones. Now, for running these containers, you have two options. Number one, you can run it on EC2 containers, or you can use AWS Fargate, which is Amazon serverless support for containers. Now let's look at them one by one. When you choose EC2 for running containers, you are basically running your EC2 container agent in EC2 instances that is owned and managed by you. Usually, these container instances are running in an auto-scaling group, but scaling of these instances can be really challenging. And although AWS has ECS cluster auto-scaling, but still Fargate is by far a much easier choice because it manages the task and scales automatically for you. So no execution handled manually by you if you're using Fargate, and no worries about scaling when needed. It's all managed by Fargate. Now you might ask, what is the difference between ECS and ECR? I know this can be a little confusing sometimes. So in simple terms, ECR, which is your Elastic Container Registry, is kind of your Docker Hub environment. And you can have ECR contain all your Docker containers and have ECS, which is your Elastic Container Service, to deploy it on AWS. As simple as that. Now let's look at the next one, Amazon Elastic Kubernetes Service, or you can call it EKS. And EKS, it simply runs the Kubernetes management infrastructure for you on the AWS cloud. And this is basically a fully managed Kubernetes service on the AWS platform. Now you can also run your Kubernetes cluster using AWS Fargate, like similar to one we discussed before. And you can remove the need to provision and manage the servers. And EKS is also certified Kubernetes, so you can leverage all the benefits of open source tooling as well. Let's look at another one, Amazon Lightsail. Now think of Amazon Lightsail as this. For $3.50 on a monthly basis, you can have everything you need to build your lightweight application, or let's say a website. Like a virtual machine, you can have SSD based storage, you can have data transfer capabilities, DNS management, and static IP addresses. So you can go on AWS website and look at some of the packaged offerings from AWS. That is basically Lightsail. For example, in $3.50 on a monthly basis, you get about 512 megabyte memory, 1 core processor, 20 gigabyte SSD disk, and 1 terabyte of data transfer. Now let's say if you're paying more, $20 per month, you get 4 gigabytes memory, 2 core processor, 80 gigabyte SSD disk, and 4 terabyte of data transfer. And same kind of packaging you have for the managed databases as well, for the load balancers, and if you want to back up your data, you have all the options provided in the Lightsail service. Now let's look at the other one, which is AWS Batch. Now as the name suggests, it is a fully managed service that runs hundreds and thousands of batch computing jobs for you on AWS, which means that you don't have to install or manage anything, and AWS does that for you. It also provides cost optimization by dynamically provisioning EC2 or Spot instances based on the requirement of the job. You can also configure your AWS batch compute environment with requirements such as type of the EC2 instance, the kind of subnet or VPC configuration you want to use, and also specify the amount that you're willing to pay for the spot instances. It can run multi-node parallel jobs, so you can have massive workloads as single jobs spanning across multiple EC2 instances. Now let's look at the other one, which is AWS Elastic Beanstalk, and this is basically the PaaS or platform as a service provided by AWS, and it allows the developers to simply run the code in kind of multiple languages. So you can have Python, Java, Ruby, Go, Node.js, and many more different languages that you can run on this platform as a service or on Elastic Beanstalk. And you can do that without worrying about the deployment, capacity provisioning, load balancing, or even auto scaling. And the user pay for storage and the service that they're using in AWS. It also complies with multiple industry standards like ISO, PCI, SOC1, SOC2, and 3, which means that it can also be used to process regulated finance data or the PCI data as well. Now let's look at AWS Fargate. And AWS Fargate, which we have already discussed 2 times before, is a serverless compute engine for containers, which means that you don't have to manage your servers or clusters or provision, configure, and scale clusters of virtual machines to run the containers. It's all handled by AWS Fargate. Now, when you're using Fargate, all you have to do is package your application in containers, specify the CPU and the memory requirement, apply the security, and you can then launch the application. Let's look at the other one, which is AWS Lambda. Now, AWS Lambda, something which is quite often used by the customers, by AWS customers, is a serverless service which developers can use to run the code without provisioning or managing the service. Now, you can also create small functions which can be triggered as and when needed. It can also be used to invoke any other service within AWS. A simple example can be that when you take a video and upload it into Amazon S3, which is the Amazon storage, you can create a trigger to invoke Lambda function to transcode the video so that it can be viewed in multiple types of devices like laptops, mobile, tablets, etc. So it's basically a function as a service, or it's a serverless environment for you to create functions which can trigger different services within AWS. Now let's talk about the other one, which is AWS Serverless Application Repository. And this is basically a repository of many applications, many partner applications that developers can search through for common use cases. It enables teams, organizations, and individual developers to store and share reusable applications. Using the Serverless Application Repository, you don't need to clone, build, or publish source code before deploying it. Instead, you can just use the pre-built applications from the repository in your serverless architecture. Think of it as a partner library of applications that is accessible to you for faster time to market. Now let's talk about the next one, which is AWS Outpost. So when you want to run AWS infrastructure on-prem, that is exactly what AWS Outpost service is all about. If you have, let's say, a really low latency requirement, AWS provides you with a service to set up same infrastructure on premise, and you can use all service APIs and tools that you want to build and run your on-prem applications. You can also connect the Outpost to your nearest AWS region, so you can access full range of AWS services on the cloud. And let's look at the last one, which is VMware Cloud on AWS. Now, as the name suggests, This is nothing but a partnership agreement between AWS and VMware to have VMware customers extend their on-prem virtual environments to the AWS cloud. So in short, folks, this is what AWS Cloud Compute Services is all about. Thanks for watching.